Thanks, everyone. My name is Rob Grasso. I'm from Yosemite National Park. I'm the aquatic ecologist here in Yosemite National Park. I will try to use the best of my time of your abilities. I will monitor the chat, and I would say, feel free to interrupt, ask questions along the way if something grabs your attention. I like to keep this talk pretty as informal as possible. Just because I think the discussions are really, where you get into the gist of a lot of projects. I'd love to talk about everything we're doing in very specific detail, but there's unfortunately not enough time for that. I think the common theme right now in California and the West, and I know in other parts of the world, is sort of the drought-related climate change effects that we're experiencing here in Yosemite, as well in all other parts of the world. And, sort of what does the future hold, at least in this context for Yosemite National Park and aquatic wildlife restoration. The species we study and try to restore depend so much on water, but we're just seeing such variations in year to year here in the park that some of the objectives that we originally started for, targeting species restoration, we've really been met with challenges. So I'd hope to dive and delve into that a little bit more. This is a picture of Yosemite Valley looking over what we call tunnel view. This was taken in the middle of the pandemic, so you can see that this visitorship is usually not this low in the park. So just to familiarize yourself with this area of the world, we are located on the western United States, in California, right next to the Pacific Ocean. The Sierra Nevada mountain range that comprises most of California and partially goes into Nevada. You might not typically think of a 400-mile long, 70-mile wide mountain range as a sky island per se, but the Sierra Nevada kind of is that ecological niche in this part of the world. Most of the mountain range is surrounded by deserts to the south, the southeast, the east itself, and to the north. There's more mountainous regions as you get into the Cascades. And then in the interior of California is the Great Central Valley, which is not necessarily a desert, but very dry in the summers. Our climate is characterized as sort of a Mediterranean climate, right? We get most of the moisture that we get in the Sierra Nevada in California comes in winter, basically between December and March, and the rest of the year is primarily dry. And I've heard other folks sort of make a joke or make a reference to California that, of all the Mediterranean climates in the world, like California seems to be the most Mediterranean. Like most Mediterranean climates still get like rain occasionally in the summer months. We get basically none. So we rely really heavily on snowpack, water permanence, and groundwater systems that are really important for amphibians in the Sierra Nevada. And sometimes that just doesn't come. Just to give you a perspective of what you might think of the Sierra Nevadas, the range of light, is high mountains punctuated by, glaciers, high elevation lakes. This is the site of Bernice and Gallatin Basin that sits around 10,000 feet in elevation, over 3,000 meters. In the Sierra Nevada, there's beautiful waterfalls, there's water permanence, and then you follow down into the subalpine where you get into forested habitats. This is a common, theme in the mountains of the Sierra Nevada. Some of the species that the Sierra Nevada is home to that we study, certainly not all, but just a sort of a quick snapshot. The western toad, the California red-legged frog, the foothill yellow-legged frog, Sierra chorus frogs or Sierra tree frogs, Yosemite toads, western pond turtle is kind of our honorary amphibian. They are very much an aquatic as well as terrestrial turtle here in the park, and the Sierra Nevada yellow-legged frog, which lots of studies have been done. The species has been a very focal part of global amphibian conservation, mostly for its persistence due to the amphibian pathogen Batrachochytridium dendropitatus, the amphibian fungal disease that causes chytridiomycosis. This is one species in the Sierra Nevada, sort of in a temperate latitude that's persisted with the fungus in high elevation cold environments. So, sort of getting back to my initial opening of, what we're presented with here doing species conservation in Yosemite and in the West is just, we've always been planning for climate change as this thing that's on the horizon and that's coming toward us, but it's not quite here yet, and maybe nobody believes that that's true anymore. And we certainly don't. We are just met with such great interannual variability year to year that it's just really hard to predict, and to conduct species reintroductions and know that they're going to be successful. So this is just a screenshot of Yosemite Valley in 2017, where we just were met with I think we were 230 or 40% of average of our annual precipitation, and then here we are in 2020, 2021, and 2022, met with maybe 30% or less of our annual snowpack, and just precipitated by just extreme drought conditions. So we flip-flop from extreme wet to extreme dry, and then we seem to fall into these consecutive dry patterns. And then, of course, you have this picture taken just outside of my office in 2018, punctuated by those drought years with really heavy wildfires causing devastation. And one of the species I'll be talking about is related to a fire context for the amphibian conservation that we're doing. I said I would monitor the chat. I haven't been. If there's anything popping up, just maybe give me a heads up, Carrie, if you see something coming in.
Yeah, I'll be watching it.
Okay, thanks. So one focal species, as I mentioned, the Sierra Nevada yellow-legged frog, Rana sierrae, has been studied for decades now. This is a high elevation frog that persisted in landscapes without fish. So when much of the Sierra Nevada was glaciated, fish could not navigate, the high waterfalls. You think of Yosemite Falls and, all the iconic waterfalls were amazing fish barriers, but not for frogs. So frogs persisted in these high elevation landscapes for millennia until fish were intentionally introduced for recreational purposes that led to pretty wide scale declines. We've studied fish introductions very heavily. We've studied BD and the amphibian fungus very heavily. We are making strides at higher elevations, but when you move to sort of lower elevation, meadow environments where this frog persists, it kind of presents a different story. And it's been, a little bit of a challenge for management, because, what do you do? How do you mitigate the impacts of climate change on meadow populations of Sierra Nevada yellow-legged frogs? And, we don't have all the direct answers, but we are moving forward with some management actions that I'll talk about. So we've been monitoring this meadow alongside USGS, who's been studying this meadow for over 20 years. And the first time we saw it go dry was during a prolonged 5-year drought from about 2011 to 2016. This frog species is known to have a larval stage that lasts up to 4 years. So, eggs are laid and then tadpoles remain up until a 3 or 4 year period before they metamorphose. One reason why fish were so sort of destructive in the original declines of the species is just a lot of time for a frog to be eaten or a tadpole to be eaten by fish. In studying Summit Meadow, we've actually learned that these frogs can actually metamorphose in 1 year. This was not known, working on a publication on this, but we didn't know prior to studying Summit Meadow in a little bit more detail that the species was even capable of that. But at these elevations, they are. And that's just one thing about our Mediterranean climate, is that our species are already pre-adapted to some level. There's some plasticity built in for just these extreme dry summers that we experience. And, I mentioned that there's the buffer of the snowpack and lakes and higher elevations that, don't impact lower elevations as much, but, we do see, and have that favorability, at least we think we do, built into some of these species for the conservation. This is a pit tagging monitor that we set into Summit Meadow. This is like the last area of pooling water connected to groundwater. So this is like 10 degrees Celsius water. not really where the frogs want to be. And you can see it's very turbid. But this is kind of like where the frogs hang on until things go completely dry. And this is just a frog enjoying this pit recorder. This is a passive integrated transponder reader. And this one's a battery operated antenna that you can deploy into the environment. All the frogs have been microchipped, or most of the frogs have been microchipped in the system. So we deploy this in the last water body to just sort of get a sense of who's around. And what we've learned, since 2011 is that before that prolonged drought, there was probably 300 plus frogs in that population. By the end of the drought, we think that number had been dipped around 2016 to below perhaps 50 or 60 animals. And today, unfortunately, since we're moving into 2022 into another dry season, we think this population could be below 30 animals. So we've enacted an active salvage program where we collect tadpoles that are desiccating, move them to a zoo rearing facility. Our repository is the San Francisco Zoo, hold those animals for about a year and then release them back as small post metamorphic animals. And the conundrum is that there are actually permanent water sources not far from this meadow. This is nearby McGurk Meadow, about 2 miles to the east, where permanent water does persist in the system. Unfortunately, fish have been introduced into the system and are the primary predator of these frogs, that they can't coexist or co-occur. So one of the managing models that we're doing is can we identify if we don't have a natural fish barrier, because it doesn't make sense to remove fish from a location if they're just going to continually reinvade. So you actually need to devise some kind of mechanism, a fish exclusion device or a barrier to prevent fish from getting back into these systems. So we are in the early planning stages of trying to develop such an effort to get these frogs, from one location back into historic locations where fish are now present, that we can remove fish. But first we have to sort of enact these practices of constructing, in this case, what would be an artificial barrier to prevent fish migration back into the system. And that's met with a lot of challenges in Yosemite because, 94% of the park is designated wilderness. And really that's supposed to be sort of, untouched by humans, no presence known or felt. So when you do impactful things like bring in equipment and construct artificial features, you're sort of changing that wilderness character a little bit. So we're trying to devise ways that sort of, blend with the management. Our philosophy is generally, how much the species was impacted by the influence of humans, how much can we impose on the wilderness factor, preserving that, sort of non-human presence by the impact. Humans were responsible for introducing fish, causing the frog declines, getting them listed as an endangered species, that have sort of led to our actions to, to sort of be heavy-handed, if you will, to do these recovery actions. The next species I sort of want to familiarize you with our restoration efforts for is the Yosemite toad, Anaxyrus canorus. This is another high elevation, typically above 2,000 to 3,000 meters in the park and in the Sierra, where it's endemic, that has also experienced widespread declines. And it hasn't been as clear why Yosemite toads have declined, but there's very strong parallels when the amphibian chytrid fungus moved into the park and impacted other species like Sierra Nevada yellow-legged frogs. Yosemite toad declines were happening sort of in concert or in tandem with those declines. So disease is strongly, applicable to the declines of the Yosemite toads, but we don't have, sort of the smoking gun. My master's research study focused on fish introductions on Yosemite toad populations, and I did not find a direct connection that fish were a direct cause of initial Yosemite toad declines. One of the examples I want to walk you through, we're attempting to do a pilot Yosemite toad reintroduction. Sierra Nevada yellow-legged frogs have been reintroduced to multiple places throughout the Sierra. Other species have as well, but Yosemite toads, it's never been done before. Many have attempted, including myself, to rear them in captivity unsuccessfully. People have brought in emergent metamorphs or adults and been able to keep them alive in captivity. And a few years ago, we did a trial experiment with the San Francisco Zoo where they brought eggs into their facility and successfully reared Yosemite toads through and are now holding 4 and 5-year-old animals. So now we know it's possible. So we started looking for, well, where might this management tool be implementable? And then this example is one I want to walk you through in the park. So, going all the way back to 1987, we sort of, have a meadow in the park, a forested meadow, which is typically in the red fir zone, well forested, punctuated by meadow habitats for breeding. So the toads show up to really shallow snow melt meadows in the spring, lay their eggs in about 4 centimeters of water. Very rapid metamorphosis, sometimes as little as 4 to 6 weeks, and up to 8 weeks, but they get out really quick. Explosive breeders, breed for 1 to 2 weeks, metamorphose, and then it takes quite a while for young of the year to reach adulthood and maturity. But in this example, we've been studying this meadow, revisiting it, finding toad populations for a few years. And then in about 2004, we had a fire come through the area. Populations were still persisting until about 2012. But you can see, and I'll just toggle through, from that original 1987 photo, you see a nice, what we would see in Yosemite toad view is a great mix of breeding habitat in shallow snowmelt meadows in the center, followed by upland habitat that the adults retreat to post-breeding for foraging and, upland dispersal. After this 2005 fire, toads were still present in 2012, but then we had another fire come through in 2013 and just burn this area over again, leaving very little upland structure behind. In 2017, it appears that the breeding habitat has reestablished, but as you can imagine, trees grow slowly when you have high severity fires, soils are compromised, regrowth just is not that rapid or recurrent. And what makes this area interesting, we've kind of nicknamed it, it's as Toad Island. It's the meadow circled in blue on the left of your screen. And if you look over to the right, these are where the nearest meadow complexes are, about, 2 miles, 3 or 4 kilometers away to the east, where extant populations of Yosemite toads are still persisting, but there's not any nearby or adjacent meadows to Toad Island, again, the meadow circled in blue. And we think, there's very little chance that this meadow is going to be recolonized very quickly. It's possible, obviously toads were there and recolonization does happen, but this is a declining species. So dispersal rates are just not that high in general. Previously, we've not really studied what the fire effects are on this species. We are just sort of getting into that. But I just also want to draw your attention to the lower left-hand side of the screen where you can see those elevational contours dropping off very rapidly. We are right at the edge of this toad's elevational range, which is roughly considered to be like the rain snow line. These toads experience a brumation period in the winter when they're under snow. When it melts out is when they breed to trigger. Western toads that are a little bit lower elevation may have a very shorter or sometimes no brumation period at all. So, to the west, we are very much pushed right up against this species elevational boundary and extent. We've been surveying it now for 4 consecutive years, and we have not rediscovered toads in this site. So now it has become a reintroduction candidate, and we will be collecting eggs and tadpoles this summer to reintroduce. So I just wanted to sort of, now bring you down to the ground level and show you in 2012, after that 2004 fire, but before the 2013 rim fire, there was still intact habitat, you would say, yes, it's been burned, but there's still some live trees, reforestation chances look pretty good, and the species was still present. So we were able to detect breeding, occurring in the areas that we normally do. This species has very, very high site specificity, and they always go back to the same areas to breed. So they're very predictable when you're looking for them. After the rim fire, looking at it in 2020, you can see things have thinned out quite a bit. And the breeding habitat seems to be largely intact, roughly 7 years post-fire. But we've been unable to detect breeding or any presence of any life stages at this site since then. and then just sort of walking you out from the meadow to give you a better perspective. The upland habitat is, just as not or more important for adults foraging and for cover and for that winter bromation period, being protected from winter snowpack, that there's very little upland habitat left. So we think, this area may be attempting to be recolonized. Maybe it will someday, maybe it'll take decades before it's reforested, but this is the area that we've decided to target to intentionally bring animals into a captive rearing facility and then release them. Probably the species is pretty slow growing, even in captivity, is what the San Francisco Zoo has discovered. So even with year-round temperatures being maintained at a, sort of a thermal optimum and being, fed on a regular basis, these toads sort of appear to grow very similar to how they would in the wild, which is maybe only, 1 to 2 centimeters, reaching sexual maturity in about perhaps 4 to 6, maybe even up to 8 years. So, and lastly, I just want to run through, I saw Tom Biebighauser was on after me. So we are in real time studying a red-legged frog population. Last year, I presented sort of on the introductions that we have done for red-legged frogs in Yosemite Valley based on the bullfrog removal that we had conducted, the invasive bullfrog removal we had conducted, and sort of opened up that niche. I presented this slide, just giving you a really quick snapshot of, what the problem is that red-legged frogs have lost so much of their habitat in the Sierra Nevada. If you look at sort of this California in section B, and the little blue dot sort of representing Yosemite National Park, we have just lost all of our red-legged frog populations, and they are just restricted to the very narrow tip of the Sierra Nevada to the north, sort of above Lake Tahoe, if you will. And, the yellow question mark in column A, or the left side of this figure, wetlands were drained so fast in California that we didn't even know the species wasn't even detected before wetlands were drained. This is an aerial view of Yosemite Valley. So there's kind of like the village in the middle and El Capitan a little bit to the left, and Half Dome over to the right. I didn't know this was even a thing until I got to Yosemite National Park, or before I really met, my friend Tom Biebighauser. He's just like, oh yeah, you see a wetland, you drain it, and you think of a national park that this isn't something that occurs, in a place like this, but we blew up terminal moraines to get rid of water faster because of roads and infrastructure and people and access, and then started taking it one step further, installing these clay tile drainage systems, and this is something that I never even knew about until I met Tom. And I don't want to steal his thunder, but I never thought like something like this would be devised in like a Yosemite National Park meadow, but it was. And this is just sort of a map of installing these basically clay drainage tiles in an array that will drain a meadow dry. They're deposited at a depth of like 3 or 4 feet. And they're really efficient at getting a meadow to a grassland, which in the park was to prevent flooding of campgrounds, camping areas, and then utilizing areas for livestock. So the example I just sort of want to walk you through at the time I have left is Royal Arches Meadow here in the valley. This is the meadow pre-restoration. So it was used by wildlife and habitat. Here's a bear walking through, and you can see some tule reeds in the background. This is a emergent vegetation that is very commonly associated with red-legged frogs in their native environment. And when we poked around, this is about as much water as we found. This is about a dinner plate's worth of water. Maybe there's 5 gallons in there. And then we just started poking around, and Tom suggested, there's probably a clay drainage tile system in there before we knew that map existed. And I just thought, that it couldn't be. And we traced over to the river, of course. I pulled out, this like 2 long foot section of clay pipe, and then started poking around, and then found water coming out of it. And then a week later, found like full discharge. This pipe was just raging, spewing water out. And I think even the tree on the left side of this photo was actually irrigated or undercut from the velocity of the water, and it basically eventually fell over. Is how we discovered it. Prior to that, it was probably at the base or under this tree root, just going undetected. So we developed a planning effort So it's basically, step one. I said, well, Tom, what do I do? This meadow's a very culturally sensitive area. He said, well, stick a cork in it. So I literally went and bought a rubber plug. I had no idea what was going to happen. I'm not an engineer. I didn't know if I was going to plug up a very, rushing, flowing system, how much head pressure that was going to create, and, damage a visitor or create impacts or, blow up in the meadow. I had really no idea, but I just said, all right, we'll do it. We plugged it. And I intended to come back like maybe a week or two later. And I came back the next morning. And that little 5 gallons or puddle of water, as you can see from just plugging the pipe, like flooded the meadow overnight. It was truly incredible, remarkable. I had no idea, no context that just how efficient these drainage systems could be. So in 2019, we implemented a drainage tile removal. As I mentioned, the site was pretty culturally sensitive. There are some Native American burial sites nearby, so all the work was done by hand. And we removed, what we could find of the system. We don't know if the full system was ever employed, but this pipe was actually built to drain the wettest portion of the wetland. So we removed, about 75 to 100 linear feet of pipe. And then a year later, it is now a functioning wetland. So this is a picture taken in 2020. And we thought it looked so good that we decided we were going to reintroduce red-legged frogs to this meadow. And in this year of 2022, we observed the first breeding that we had ever detected. So, we thought it might be good frog habitat. We restored the meadow, and then it became good frog habitat. And then actually the frogs finally bred. I don't know if this will go, but this was just taken last week. So, hopefully, Tom, this is a nod to you for, helping us getting this meadow restored, is that we actually have California red-legged frogs successfully breeding. And these are tadpoles emerging from the egg mass in the system. So, and then I think I'm pretty much getting close to my end of my time. So I'd like to, address or answer any questions and just, thank most of our partners in coordination with this, the Yosemite Conservancy, the Dorrance Family Foundation, the San Francisco Zoo, and U.S. Fish and Wildlife, and to my staff, Nanette Daniele and Carson Lillard, who work with me in the program on a lot of these projects and are, heavily always helping behind the scenes and helping these restoration efforts move forward. So, hopefully there was some inspiration in there, despite the challenges that we're met with. And then at this point, I'd be happy to take any questions. Thanks.
Thanks a lot, Rob. I actually have you scheduled for another 17 minutes, so we have plenty of time for questions, or if there was anything that you left out, then you can add it in. We did have one question that came in during the talk, which is, what is the elevation of Summit Meadow?
Summit Meadow is 7,000 feet. I think just around 7,000. So does that translate into meters? Around
2,100, 2,200.
So, yeah, and it's, Summit Meadow is just, we don't really know why or how the frogs are persisting there. The obvious answer to us is that since it goes completely dry, is that fish don't persist there. So fish obviously need permanent sources of water, and yellow-legged frogs do, but they can also survive in sort of wet, moist areas like undercut banks, rodent burrows. There is a stream channel at the outlet of Summit Meadow, that they can retreat to, and rocks and cracks, where it's either moist or maybe slightly damp, and again, just not conducive for fish to survive. But allows the frogs to sort of persist. But, this population is, we know now all of our populations in the park are positive for the amphibian chytrid fungus. So this frog is, not only dealing with the consequences of drought and extreme drying and, for all intents and purposes, complete loss of all cohort reduction every time there's a dry year, which now has been collectively over the last 10 years, 7 out of those 10 years have been almost complete cohort reduction or loss, that they're still persisting on the landscape. And now we've sort of implemented this active management strategy at Summit Meadow where we do intentionally salvage, 100, 200 to 300 tadpoles sometimes rear them in the zoo, release the majority of them back to Summit Meadow a year later, regardless if conditions are wet or dry. But now there are other meadow populations around Summit, I would say within a, 4 to 6 kilometer radius, that there's just no interconnectivity because of fish, that we're actually starting to move frogs into those others as sort of a, you could call it a genetic rescue effect, if you like. We'd like to be guided more by the genetics when we can, and we do have really good genetic results for this area that gives us confidence when we're moving animals around, that we're not changing that dynamic too much on the landscape, but sort of artificially trying to compensate for that fragmented habitat due to fish by simulating that interconnectivity by putting summit frogs in other meadows. So yeah, I know when I went through it, I'm a fast talker, so I figured there would be more points we'd be stopping and asking questions, but I realized I ran through it pretty quick. So yeah, I'm definitely willing to stay on and dive into any more deeper details on any of these projects we're working on, or if people have interest or questions about other things we're working on, I'm happy to dive into that as well.
All right. Yeah, we do have a few more questions. And yeah, I want to say a great ending to that presentation with showing us that wetland just from removing the historical drainage. That's good news. And so, yeah, I want to say hello to Frederica, volunteer, I believe, from New York, who came out to California to help build some wetlands last summer. And the story of those wetlands, I just chatted in a link that's from up in Tahoe. We also have Saeed, a Save the Frogs grant applicant and amphibian biologist from Iran, showed up. All right, so a couple new questions. Does the NPS, the National Park Service, reforest after fires?
Traditionally we have not. So there's a couple things that we have not done historically, but we are starting to do presently. One is actually doing active forest thinning, which typically you may associate with either state agencies or the Forest Service, which manages its federal land holdings as multiple uses. So there might be motorized recreation, off-vehicle recreation, timber harvest. Given our devastating wildfires of the West in these extreme drought years, the big risk has come up is, are we going to lose our giant sequoias? We know from 100 years of fire suppression, every time a lightning strike struck in summer without rain or even with rain, we rush to put it out. In the park, we try to manage natural ignitions, as we call lightning strikes, as best to our ability. Without getting into like the super weeds, the state and the West is basically put on an alert level. Much like you might be for wartime, we sort of get into a fire wartime scenario where we get into level of categories. And if the risk is low and the tolerance is high, you can let lightning fires burn on their own. Or if, resources are spread thin because fires are burning everywhere, then that mentality comes back of like, squish it, dump a tanker on it, get crews out there, put it out as fast as possible. But the practices started getting park managers thinking of like, well, we need to be doing more forest thinning and management. We hadn't done this before. So in our Mariposa Grove of giant sequoia trees, we actually are doing like, akin to like commercial thinning to bring down some of the understory that traditionally would have burned in a natural fire regime. And at these elevations, people's guesses are that's around 7 to 15 years a natural fire would have come in and burned the understory. And with fire suppression, that fuel loading has built up. So, it's the artificial way to simulate fire by removing what the effects of fire would have been by mechanically removing. And then to answer your question, yes, I heard Sequoia Kings, after their devastating fires in 2021, is actually applying for some grants for some reforestation for some of those areas. And I think, much like I mentioned, us working in wilderness about, how much of the problem was caused by, a human trigger or a human influence. Do you repair the damage based on that? It probably is hard to argue that it's a natural ignition from lightning, that you should go out and actively reforest that area. But if you have somebody who had their campfire, get away from them, when there was no lightning storm around, and significantly burn an area, that maybe would have made it through, had humans not been present or fire been accidentally introduced. That, maybe there's other species, like fisher or other tree dwelling animals that depend on habitat, that there's a need to sort of reintroduce that reforestation effort. But I think the parks are starting to get into that mentality of like, it could take decades, because we're no longer burning, dozens of acres or a few hundred acres from these wildfire ignitions from natural systems like lightning. But now we're getting into the tens or hundreds of thousands or into the millions of acres that reforestation practices, largely for the benefit of wildlife and habitat, seem to be the management tool people are looking to use. Long-winded answer, sorry.
Thanks for that. All right, next question. Is chytrid affecting the Yosemite toad as well? I'm pretty sure it was affecting it 10, 20 years ago. What do you think about that, and what do you think has changed in the past 20 years, if anything?
Yeah, so great question. I mean, the presence of an animal in the landscape, and persisting with BD is a testament in and of itself that the animal is capable of surviving, right? Whether they got through some bottleneck in the past during original declines and they're somehow finding a way to persist. As Carrie mentioned, yeah, we think a lot of our initial declines happened from the 1970s on to the early 90s and early 2000s. And including Yosemite toads, and the disease is persistent in that species. What the long-term effects are on populations, are not as clear. Most patterns hold true, whether it's Sierra Nevada yellow-legged frogs, red-legged frogs, Yosemite toads, is that vulnerable life stages, that sort of that first 0 to 3 months post emergence. As metamorphs, they shut their immune systems down completely when they go through metamorphosis, and they develop all that keratinized tissue in their skin. So that's the most vulnerable phase, it seems like, for most amphibians, and we think that's true for Yosemite toads. But if they can somehow make it through that bottleneck, that their chances are pretty good. They're already a very risky breeder. They, as I mentioned, they breed in 4 centimeters of water, so that's very highly, susceptible to desiccation. But it also means when the sun hits an open meadow, that water is warming up to, 30 degrees C, which is sort of getting out of the thermal threshold, above the thermal threshold for BD. So these animals may just have some predisposition to sort of shed or rid themselves of BD. Sierra Nevada yellow-legged frogs that I mentioned are spending 2, 3, sometimes 4 years as tadpoles. That's a lot of time to sort of fester a BD infection, but it's also a lot of time to get you exposure to it. The toads are out in 4 to 6 weeks, so we don't even think tadpoles develop any signs of fungal infection. And then adults, once they breed, unlike frogs, they immediately go into like forested upland habitat. So, they're, again, a little bit predisposed as a drier animal that just sort of needs to go and drink water every few days versus being immersed in water. Also sets up their defenses a little bit better for BD. But, it still has to beg the question. When you look at similar species like Boreas, Anaxyrus boreas in the Rocky Mountains, and the Wyoming toad, that sort of were met with just these widespread, severe declines, like all the way to extinctions in a lot of cases. That didn't happen with Yosemite's toads in the Sierra. And, we have to ask, well, why is that? Is there some evidence that, there is some resistance to BD built into these populations already? We know BD has been persisting in the Sierra, in California and other parts of the world, museum specimens going back to the 1850s. It's possible that our species have actually seen BD long ago in the past, that something's built in that allows them to sort of get through these bottlenecks when they crop up again in future, episodic events. So.
Thanks for that response. Let's see, we probably have time for a couple more. How did you get toads into Toad Island? Were they hiked in?
Oh, so we haven't actually done it yet. So we are, the survey protocol for Yosemite toads, and I didn't mention this in my talk, is that they are known not to breed every year. Resources are very limited for this species. We know from dispersal studies that males tend to hang around maybe like the first 50 to 100 meters of, the riparian boundary of a meadow, and the females go much further, like 150 to sometimes 300 meters out. And their diet consists largely of, not very nutritious prey, and probably hard to digest prey like ants and beetles. So we know that adult female Yosemite toads don't breed every year. They breed more typically like every 3 years. So, that in and of itself is just like, when you get a dry year, we also know they can forego breeding altogether. Females just show up, there's not enough water, they don't even breed. So in order for us to know that a meadow has truly extirpated, we want to survey at least 3 consecutive years to be like, okay, we just didn't show up in an off year and they didn't breed this year because it's dry, and we wouldn't have expected them to. 2022 will be our 4th year that we've actually surveyed Toad Island and confirmed non-presence. You can do things with eDNA, although we found eDNA to be a little bit tricky with toads. You wouldn't suspect environmental DNA, and like snow melt water would be difficult to filter, but there's a lot of tannins, a lot of pollen that have made eDNA a little bit tricky for us. We're relying on traditional visual encounter surveys, but our project being implemented this year is to simply collect Yosemite toad eggs from one location, one meadow, rear them for a year, and then in 2023, and hopefully this will be a future presentation for you all, is we'll be reintroducing them, probably 2 to 4 years out. These toads don't get very big their first year. So we're a little concerned if we only wait 1 year and release them in 2023, they might not be large enough to navigate or survive on the landscape. We're kind of hoping for a 2 or 3 year toad, that might be, 30 to 40 centimeters. That's probably pushing it, and releasing a little bit larger subadult on that landscape. But yeah, it's still very much in the planning. Not to say that given we're in this salvage situations present themselves very well for this species, because again, they're in 4 centimeters of water, and when there's not enough water, tens of thousands of tadpoles dry up in an instant. So there is a chance that we may actually make a management decision if areas with tadpoles nearby are drying up, that we may actively move tadpoles into that meadow. But traditionally, moving eggs and tadpoles of species for us with BD, with the fungus, just has not been viable. Animals generally don't survive in high enough numbers to persist. So we like the older stages with, sort of primed immune systems, a little bit better defenses, and a little bit survivability with predators at older life stages to reintroduce. Oh, you're on mute, Carrie.
One final question, and try to answer it in 60 seconds or less. And then for the other questions, go ahead, chat in responses if you see questions in here that you want to answer. Sure. The question is, what methods are used to remove introduced fish?
So in Yosemite, we only use non-chemical means. So we don't use any rotenone or antimycin, which I don't think is even approved in California anymore. So no fish toxicants are used in the actual removal. So it presents its own challenges. But again, we're working in a national park. We're working in, remote wilderness. And, half the park is also the city of San Francisco's water supply. So, there could be environmental challenges that sort of go along with that in terms of environmental compliance and planning. So we use 2 primary methods. We set gill nets of variable mesh sizes, and they are submerged in the lakes, and it's just a chance encounter that fish swim into them and then they're removed. We set them all year round. So they are set near the surface in summer and then under ice in winter. We have very specific sets for that. And then it generally takes about 4 to 6 years, sometimes longer, depending on the size of the lake, to remove the fish. And then for inlets and outlets, we use electrofishers. So we use backpack mounted electrofishers that are fishing the water to basically turn and capture or stun fish. Our water is so pure that there's very little electroconductivity. So it's mostly just like stimulating a fish long enough for somebody to catch you with a dip net. So
a huge thank you to Rob Grasso, and best of luck with your continued efforts. Let's close that out. Yeah, thank you so much.